My name is Kevin Kircher. I'm an assistant professor in the School of Mechanical Engineering at Purdue University. So collectively, the energy that we use in our homes and our vehicles cause something like half of US greenhouse gas emissions. And one good way to reduce the climate impacts of all of our personal activities would be to switch things like space heating and water heating and cooking and driving over from fossil fuels to electricity. This has the potential to lower utility bills. It also has the potential to reduce greenhouse gas emissions significantly, especially if the electricity that powers all those new devices comes from clean generation sources. So electrifying a home means replacing the fossil-fueled equipment that we have in our homes with electric machines that kind of provide the same services. So for example, many of us have natural gas furnaces or boilers that provide the heating that comes out of our ducts or radiators. And so electrifying a heating system would generally mean switching to an electric heat pump, which is an efficient electric machine, a bit like an air conditioner that can run in reverse, that can provide low cost and clean heating for a home. Another example of electrification would be a water heater. So many of us use, for example, a propane or a natural gas water heater, and that could be switched over either to an electric resistance water heater or to a more efficient heat pump water heater, which might cost more upfront but would use about half the electricity. And then finally, electrification can involve various other appliances, things like stoves and dryers, replacing these things, and crucially replacing the fossil-fueled vehicles, things like the cars and trucks that we fuel up with gasoline, and switching those over to electric vehicles. While switching to electric heating, water heating, and driving could reduce emissions a lot, it also could drive electricity demand significantly higher than it is today. And in particular, the peak electricity demand that might happen in the most extreme weather conditions could be much higher than what we experience today. And those new peaks in electricity demand would put new strain on electricity grid infrastructure, and particularly the distribution grid, which is kind of the component of the grid that our buildings plug directly into, by contrast to the high voltage transmission grid, which is the big power lines that you might drive by in a rural area on a road trip, something like that. So in this paper, we investigated what would happen to electricity distribution grids if we electrified all the homes and private vehicles in the United States. And we found kind of there are two cases. If we don't do anything, we will drive peak electricity demand well beyond the safe limits of today's infrastructure. And that could put power reliability at risk and potentially lead to increased frequency and duration of blackouts. On the other hand, if we do reinforce the power grid to accommodate all the new electricity demand growth, then we could find that the cost of adding lots of new infrastructure to the grid, things like thicker power lines and bigger transformers, could be on the order of $500 billion, which is about $5,000 per household in the United States. So we investigated three strategies for mitigating the required upsizing of electricity grid infrastructure. One involved reducing the demand for heating and cooling in our buildings, and that could happen, for example, through insulating and air sealing buildings, but it could also happen over time through a gradual shift from more detached single-family housing, like you might see in the suburbs today, to attached multifamily housing, things like row houses and condos, which tend to have much lower heating and cooling demand per square foot of floor area. That was the first, is more efficient building or reduction in thermal demand. The second strategy we looked into was more efficient equipment. So kind of in our baseline scenarios, we looked at electrifying heating and cooling equipment with basically the equipment that's available today. The main version of which that's used in the United States is called an air source heat pump. So in a comparison study, we looked at more efficient heating equipment, geothermal heat pumps, which typically use less than half the energy of today's kind of standard air source heat pumps. And then in addition to those two strategies, the third that we looked at was coordinating when devices operate. So for example, to stagger the operation of an electric vehicle charging station with the operation of a heat pump, so that we don't have all the devices running full blast at the same time. And these are strategies that we've investigated to various degrees in hardware at our test house here at Purdue University. In the study here, we found through modeling that if we use the combination of all three of those strategies, that we could reduce the required reinforcement of distribution grids to accommodate electrification by something like 2/3. One surprise that came up in the study was that the third strategy that we investigated, coordinating when devices are operating, was surprisingly effective. So on its own, it reduced the required grid build-out by about 40%. And that's more than either of the other two strategies that we investigated sort of individually. And the reason that for me that was surprising is that the other strategies, so insulating homes, for example, or inventing and deploying much more efficient heating and cooling equipment, those are complicated and they can be time intensive, and particularly they can be pretty expensive for the homeowner. So by contrast, coordinating when devices are operating is fairly inexpensive. It requires mostly software and communication, things like smart thermostats and smart EV chargers, which are increasingly being adopted already today for other purposes. And yeah, the effect of it, by coordinating all of those devices to reduce the required grid build-out by about 40%, which is hundreds of billions of dollars across the entire United States, it was really surprisingly effective.